in order to support the next two presentations, which are getting down to the real stuff, I mean, to the real technology. Okay, so I'm going to cover this subject, I mean, big data, big Earth data, but more generally, of course, big data analytics. And we know very well, I mean, that this important step here, the analysis of bigger data, is useful in order to uncover hidden patterns, correlation, trends, and insights. I mean, the objective here is to extract what are commonly called, insights, if you like, you can call it knowledge, in order to take informed decisions. When we talk about big Earth data, and more generally big data, I mean, we are very well acquainted with the challenges. It is popular, it has been popular to talk about the 5 V's, you know, 5 most important challenges, starting with the letter V: volume, variety, velocity, veracity, and value. I'm not going to cover them because I'm sure that you know what are the challenges. My point today is that we have entered recently in a new era, even in big data, the artificial intelligence era. And so also these challenges has changed. I mean, we have changed our capacities, and they have changed in terms of opportunities, but also possible issues. So when we talk about volume, clearly what used to be big today is not anymore so big, because we have cloud, and what is big today, I'm sure that it is not going to be anymore in the next years. While in the artificial intelligence era is getting more and more important, for example, the variety, so the different types. So this is going to be more important than big volumes. And it is also getting more and more important, the velocity challenge, with, with connectivity everywhere, and, and always we need more and more real-time, or if you like, near real-time connectivity. And so, I mean, velocity, so how fast you are in analyze big data is really important. The so-called almost zero latency time is the crucial factor when we talk about new applications in different sectors, such as disaster mitigation, early warning, finance, healthcare, cybersecurity. I mean, you can add it. And the same is for quality and value, because as I said, with artificial intelligence, even those data series that didn't used to be so valuable today, they are proving to be more valuable than we thought. So artificial intelligence here, my message is, please, I mean, let's try to consider the term intelligence not as the human brain intelligence. I mean, we are not there yet. This is the general artificial intelligence. We are not there. We are talking about narrow artificial intelligence that comes, so intelligence from the Latin intelligentsia, that means intus legere, in English, to see deep, so to extract deep insights. And this is the present revolution. But in addition to this evolution, of course, we have also new important technologies when we talk about the big data analytics. They are Internet of Things, blockchains, augmented analytics, etc. So we have also to consider these, these changes when we think about what bigger data analytics is and is going to be. Success factors. Well, I mean, certainly security. In an online world, so this cyber-physical world, security data security, but also, connectivity security is going to play a major role. The same, of course, is privacy. So ethical considerations beyond privacy. We have also consent, transparency, fairness, accountability. These are all important factors. Let me also add energy. When we are always everywhere and anywhere connected, we are consuming energy, a lot of energy, in particular in order to process big data. So energy is another crucial factor. And here, just a couple of examples of what is the cutting edge in terms of Earth observation and artificial intelligence and geo-artificial intelligence. For example, when we talk about Earth observation, we have a geospatial foundational models, artificial intelligence foundation models. You may know is a pre-trained model by using generally an existing portfolio of remote sensing, commonly unlabeled. This is what I mentioned. Quality is not anymore so crucial. So you pre-train this general foundation model, and then this can be used for many different application domains. And in order to apply to your specific application, you have also to perform a fine-tuning. Okay, so this is a real important paradigm change. NASA and IBM develop, one of this kind of models by using, Sentinel and Landsat. But I'm sure that we will see more and more. And the same is if we come from the GIS sector, we talk in this case of geospatial machine learning and deep learning, and this time the concept is the geofeature, which is described by a set of vectors, which are multidimensional vectors, and they provide a sort of labeling for these phenomena. Okay, I don't have much time to go into depth, but I'm sure that this is enough for you in order to, raise your attention. Artificial intelligence of things. As I said, artificial intelligence and Internet of Things are the new revolution. When they meet, they, generate this new term, which is called artificial intelligence of things. Is a subset, of course, of artificial intelligence. And here, for example, we can talk about edge artificial intelligence. Things, connected things, are at the edge of the internet, and they sense the environment. When I talk about environment, I mean a natural environment, of course, but also social environment, the social sensing. So we generally talk about a cloud continuum, so not anymore cloud or central cloud, but something which is more, variegated. So we go from the center to the fog to the edge. So from the, from the central dimension to the edge dimension, closer to the users, closer to the things. Okay. Another important point of AIoT is 5 and 6G. So mobile connectivity here is going to play a major role, in particular, as I said, for real-time or near real-time. So that's the general picture. When we talk about analytics, we start from data pre-processing. We are in the big data, let's say, link. When we collect big data, we have also to pre-process. And here I'm referring to tasks such as data cleaning, data integration, transformation, reduction. This is pre-process. Then we go to the real analytics, the serious stuff here. And basically, there are two major methodologies or the technologies, if you like. The first one is exploratory data analysis. I'm talking about descriptive statistic, data visualization, correlation, analysis, and then modeling and data mining. And here, artificial intelligence, in particular, machine learning, is the new game in town. And here we have regression, classification, and clustering. Then, of course, the more traditional statistical analysis and the text mining. These are the two links of a virtuous loop, which can be seen as a cybernetics loop, and the last link here is the decision making, consisting of insights, generation, and actionable intelligence. This is just to explain you, when we talk about artificial intelligence, it is a bit more complex. So artificial intelligence, I mean, we know at least the 3 different types. These are general, super, and narrow. In particular, today we have only narrow artificial intelligence implementation at the operative way, yeah. And a subset of narrow AI is machine learning. A subset of machine learning is artificial neural network, and a subset is deep learning. And today, we all know about generative artificial intelligence, which is a subset of deep learning, just to explain you how technology is moving fast, and how all of these new technologies, as far as analytics, provide a lot of new opportunities for bigger data. Another important paradigm change is the cyber-physical model. I guess that I don't have to spend much word about it. We know what is a cyber-physical world. We are more and more interconnected with the physical and the virtual world, and we need new interaction patterns. And the most famous and most known is the digital twin pattern. Well, I mean, we used to work developing digital models. So you have a physical entity, you collect some data set in a very sporadic way, and you generate your statistical, static representation of the physical entity, and that's it. You can do better if you add artificial intelligence. The first condition is to observe on a regular basis your physical entity, so that you can generate what is called a digital shadow, and apply your artificial intelligence, machine learning technology. That's a key step forward, because now you can move from a static to a dynamic representation, so to infer the behavior of your physical entity and work out the simulation and predictions. Finally, if you close the loop, the cybernetics loop I referred to, then you can also take action back to your physical entity in order to manage this physical entity or phenomenon. So a digital twin is able to provide a behavior description, is able to allow scientists to simulate and predict, and to manager to take action back to the physical reality. This is also called the smartification loop. I can skip this. What we have been doing so far, I mean, collecting big data, applying these big data analytics, largely today artificial intelligence based, and then to take back action. Well, we are moving from the data to the so-called knowledge step, and for doing that, analytics is the key action in order to generate information from data and to generate knowledge from information. This is why today we have assisted to a new revolution in the World Wide Web. Today, we talk of about the Web 4.0. We used to be in the so-called data web or semantic web. Today, we are entered in the intelligent web. Or if you like, I mean, the Internet of Objects. So Web 4.0 is needed in order to support the cyber physical world and to provide personalized services, efficient automation, and advanced decision making. But it is not coming for free, because if you use software, in particular analytical software, in order to generate information and knowledge, you are taking some risk. And this is why you also have to define a set of safeguards, of guardrails, if you like, from a political, economic, and social point of view. And this is what policy commonly is asked to do, and this is why at the European Union level we launch the so-called digital open sovereignty strategies, consisting of a set of regulations and regional and multilateral standards. So my last slides here is about the need to implement a set, at least 3 important shifts, mind shifts. The first one is the so-called value chain shift. We have to move from an analytics and from a technological approach which used to be data-centric. So we generate, access, exchange, process data, etc., etc. We need to move from this data-centric mind to this knowledge generation paradigm, the pyramid that I explained before. That basically means to shift from the SDI, the spatial data infrastructure concept, to the more complex but even more powerful digital resources ecosystem. So we need to consider the data is only one ingredient of the whole smartification, or if you like, a cyber physical world. The others, resources, digital resources, are sensors, dataset, analytical models, tools, etc. Today we are here to talk about analytical models. And so we need to orchestrate those resources online. That also means to implement as much as possible a principle, a general principle, which is called no big data egress. It is a good practice not to move big data around the web, but to move algorithms, so basically models, okay, analytical models, where effective capacities are, such as big data, high performance computing, secure platform, etc. The second shift here, mind shift, is about the system of system engineering and interoperability shift. I mean, as we know very well, today we have decentralized everything. We have a distributed system, so we need more and more to implement, super system or a system of system, whatever you want to call it. And with our, with our old glasses, that basically means to decentralize data and to distribute data bases or data lakes. So we use to build data warehouse, data warehouse concepts or data warehouse systems. As I said, we have to, evolve this situation and move towards artificial intelligence on things and web as a platform, because data is only one resource, digital resource. We need also to connect others and to orchestrate them. Then, when we talk about governance, the governance models, once more, we used to develop strictly data-based federations with strict standards and rules. So, I mean, quite, clear, but also quite stiff. If we go towards digital ecosystem, we need to relax everything. So we need a more modular, evolvable, flexible, and viable governance, okay? This is because, as we have seen, technology is progressing at a very fast pace, and so we need to survive the many different changes, political, social, and in particular, technological changes. I can skip this. The third and last shift is about moving from scientific model access as services to scientific model access as one of the many digital resources. The real topic of this seminar today. We used to access a model as through a multifunctional system. So basically, we didn't access really the model, but we access, the system. More recently, we did a very important step forward by accessing the model as a service. So this time through APIs, for instance, we access the real model, but still with a very important limit. We are only allowed to execute, to run the model on the provider infrastructure. This, limit sometimes in a very important way the application development and the usability of what researchers and the developers do. So we need again another step forward, which is to share and to access models, scientific models as resources, okay? And when I talk about resources, they can be a procedure, or they can be a trained neural network. This is important for the usability, of course. Open science, open knowledge, we all know about these important, paradigms. Once more, the no big data equals principle. We have to move scientific and analytical models around the web and not data. And so, we need to develop a model as a resource framework and to provide the technical implementation. And in particular, I'm sure that Paolo is going to cover this topic. So I mentioned several times a digital ecosystem concept. I don't have time today to go into this, but just to tell you why we need this, because we need a dynamic and holistic view of this cyber physical space. And in particular, we have to consider that this space is going to change several times over time. New digital resources will arise, new organization will come, new external pressures will happen, etc. So we need to be ready and to be viable. Another important point here, which is, let's say, more social, if you like, we don't need only to preserve the so-called single organization utility. We have to preserve something which is called the ecosystem utility. So it is important for even all the private and public organizations to have, to have a thrive space, what is called ecosystem. So we need to preserve the ecosystem itself, okay? And these are some references of publications where I've been authored along with Paolo and Mattia, from where I took most of the messages and concepts that I presented today. And I've finished. Thank you for your attention.